Welcome back, fellow physics enthusiasts. Today I'm going to be discussing some vector multiplication, which is a very ubiquitous operation performed in physics in general. So it is only natural that I should discuss what that is and how to go about solving it. So this is going to be another two-part video where I discuss one version of vector multiplication and then another. So today's vector multiplication operation, that has a good ring to it, is the dot product. And what is the dot product and how does it differ from normal multiplication? Well, since it's vector multiplication, as I'm sure you're aware at this point, you are taking two vectors and multiplying them together. Now, the output when you take the dot product of two vectors is always what's known as a scalar. And a scalar is a value with magnitude but no direction. So you're taking two vectors, both with direction and magnitude, and then yielding a value without direction. So let's go into just defining that here. So if we take vector A dot vector B equals some scalar value, right? Well, one quality of the dot product is that it is commutative. So by what I mean by that is you can rearrange this equation like so and end up with the same value. So that is essentially what I mean by commutative. So first things first, we need to take both vectors and break down their successive components. That is an essential detail that cannot be overlooked when solving for any vector multiplication problem. So specifically, let's go about how to do that. Well, we need to define them based on their unit vector counterparts, which basically gives a direction at which the component is facing. And I'm going to use the notation known as E hat, which is basically the first letter of the word Einheit, which in German means unit. So it only makes sense that this would be used for unit vectors. So there's another notation that's used in engineering, which is I hat. That is to denote the x direction. So there's I, j, and k. And then you can also define it like so. So just so we're all on the same page, we can just know that these are all applicable and they totally work when it comes to solving these problems. So now that we got that out of the way, let's start defining our components. So we will have first a sub x, so our x component, e hat x, plus a sub y, our vertical component, so e y hat, plus a sub z. Now we're doing this in 3 dimensions, just so you can get a very thorough explanation. So a sub z, e hat sub z. And then we do the exact same thing for vector b. So that's going to be plus b sub x, e hat sub x, plus b y, e hat sub y, that's not a y, plus bz, e hat sub z. Okay, so now what we need to do is take our corresponding components and multiply them together and then take the sum total of those values. And I will show you what I mean by that. So this will be equal to a sub x times b sub x. So that is our e sub x component, plus a sub y, b sub y, times e hat sub y, plus, and I'm sure you've guessed it at this point, a sub z times b sub z. So e hat sub z. Okay, and then we just perform the operation and we will end up with our scalar value. And I mentioned before that when you solve the dot product, you can find out the net distance between them and the angle associated with those two vectors. And that is represented via, so like we did, A dot B over the magnitude of A times the magnitude of vector B. And that is equal to the cosine of the angle between them. So now that we got that out of the way, let's go about a little bit of a demonstration, a little bit of an example about how to solve for this, to find our distance and our angle associated with a set of vectors. Okay, so now we have our example here where we have a Cartesian coordinate plane and we have two vectors projected out from the origin. Now, what we're asked to find is the magnitude of these vectors and the angle between them using the dot product. And here we have two different formulations in which we can employ in order to go about solving for this. And we're going to go through both. So first, and the quickest method for this scenario in order to find the dot product here is to break down our components, which should always be your first step when you're doing any vector multiplication. So let's start by taking our x components for A. So vector A, our x value, if you can see here, there's a value of 5. So that'll be our x component. So we're going to have 5 e hat sub x plus, now over here, 5 is also our value for our y coordinate, for our y component. So that is 5 e hat sub y. And now let's do b. And we're going to do the exact same thing here. We're just going to have different values now. So 6 is going to be our x component. So 6 e hat sub x plus, now over on the y-axis, if you can see, is -2. So instead of adding now, we are actually going to be subtracting because it is a negative value. So -2 e hat sub y. Okay, perfect. So now let's start performing the operation where we take our corresponding x components, multiply them together, and then add both of our component sets. So we have A dot B is equal to, all right, so 5 times 6 is our first set of components, and that is going to be added to 5 and -2. So right here, we're going to have a value of 30, and then we're subtracting that from 10, because 5 times -2 is 10. So our total value here for our dot product is 20. Okay, so now, like I mentioned before, we want to find the magnitude of our two vectors and the angle. So let's start by trying to figure out the angle of each vector in their respective quadrants. So for quadrant 1 vector, or vector A, we are going to be taking the inverse tangent, as I'm sure some of you know who have taken calculus. In order to find the angle here, we are going to apply the arctan, the inverse tan, either or works. So we are going to take the angle for theta A equal to the arctan 1, where we have 5 over 5, which is just 1. And the arctan of 1 is 45 degrees. Now, the same thing for theta B, which will equal the y component over the x component. So, arctan, -1, which is -2 over 6. But since we're taking these absolute values, we need that to be a positive 2. So the arctan of 2 over 6 is the same as 1/3, and the arctan of 1/3 is 18.43 degrees. So equal to 18.43 degrees. Now let's add these two together since we are asked to find the angle between both of these vectors. So we want the total angle between them. So adding these together, 63.43 degrees. Okay, so now we have our angle. Perfect. Now we want to find the magnitude of these two vectors. So let's start by finding the magnitude of A and then the magnitude of B, and then we can confirm whether this is correct or not. So magnitude of A. We are going to be using good old Pythagoras here. Vector A is equal to, we're going to have 5 squared plus 5 squared. So it's going to be plus 5 squared, and that is the same as 25 plus 25, and the square root of 50 is 7.07. And for the magnitude of B, we're going to have the 2 squared plus 6 squared, which is going to be negative 2 squared. See how that negative isn't going to be an issue. So we're going to add that to 6 squared, and that will be equal to the square root of 4 plus 36, which is 40, 6.32. Okay, so now we have both of our magnitudes. Now, what we can do here is take these values, plug them into their respective places, and then multiply it by the cosine of our total angle. So A dot B is equal to the magnitude of, so 7.07 times 6.32 times the cosine of 63.43 degrees. And when you plug these values in, you will get a value of 20, or approximately 20, because I rounded for these values. You're going to get somewhere along the lines of 19.98. So our value is going to be approximately 19.98, which may as well just be what we originally calculated. So 20. And there we have it. That is how we perform the dot product, finding the magnitude and the angle between two vectors. Now, obviously, this was a two-dimensional problem, and I didn't use Z, but I hope that you at least get the gist of how to go about solving these problems. And the next video, I will be incorporating the cross product, which is a little more involved, admittedly, and tends to be the one that people despise the most. But I am going to show two different methods there, and hopefully it'll be intuitive enough, at least. And if you have any further questions regarding this instruction here, I would be glad to elaborate if there are any issues on your end. So don't hesitate to reach out to me, and thank you for watching.